Hello, welcome to a classic APL coding video. My name is Jamie. In this episode, I'm going to be coding the classic card game Acey-Ducey in APL 360. The version of APL 360 I'm using is copyright 1972. The version of the card game that I will be coding from comes from the book 101 Basic Computer Games, published by the Digital Equipment Corporation, and this particular copy is the third printing from 1975. It was first printed in 1973. This game was coded by Bill Pomby from Adelaide East Stevenson High School. So just a quick description of the game. You will be dealt two cards. The first card will be smaller than the second card. Then you have the opportunity to bet depending on whether the third card that is dealt will be between the first two, and then the game will keep going until either you lose all your money or you interrupt the program. So I'll move forward. The code fits all on one page. The page is broken up into two columns. The left column is the basic code, and the right side is just a sample run for the code. I'll zoom in here. Both the version of APL and this version of BASIC are roughly from the same era. This particular version of BASIC is, I'm assuming, something that ran on Digital Equipment Corporation machines back at that time. It does not include GoSub, or the author did not choose to use GoSub. So control flow is done through GoTos. It was very common in those days. And in APL 360, control flow was done through the using the branch operator, which is represented by a right arrow, and I'll be using that also. I will stick with this kind of the same layout here in the basic code in my APL code as well. There will be a couple places where we can optimize our code using some features that were available in APL 360 that were not available in this version of BASIC. Okay, so go ahead and get started. There are three lines up here at the top of just comments. I'll skip those. Line 100 is a randomized line, which just randomizes the initial seed for the random number generator. And I'm not familiar with the same type of command that would be available in APL 360. So just in my reading, I've not discovered how the random number generator was seeded, or if it is set to the same seed every time the environment starts. My feeling is that it's probably based on something, maybe the time or something that can change. So I'll do Adele. The name of our program will be AC. I'm going to follow this with, although it's not necessary, I'm going to follow it with the names of the variables that we will be using in the program. These variables that we place here on the right-hand side of the program name, separated by semicolons, will then be temporary variables, and they will not overwrite any global variables that would happen to have the same name. So I've gone through the code and just have made a list of these. We have N, Q, M, A, B, C. There's an $, which is in BASIC would be a string value with a variable named A. I'll choose AD here in APL. And then I'm also going to include a cards vector, which will help simplify printing out the cards. Okay, so now here we are in line 1, and we'll start here with line 101, and we print out just a set of instructions. So in APL, we don't need to use a particular print statement to do that. We just write these as character vectors, and then when we run the program, these will get displayed. So we have Acey-Ducey, is played in the following manner. The dealer, the computer, deals 2 cards face up. You have the option to bet or not to bet, depending on whether or not you feel the next card will have a value between the first 2. If you do not want to bet, input a 0. Okay, so you'll see there as I made a couple typing mistakes and I went back and corrected that. If I want to see a clean copy of the program at this point, I can do left square bracket, Shift L, which is the quad character, right bracket, and then I'll see those lines, or the first 6 lines printed, and the heading also. Okay, here we are at line 7. Now, in BASIC, when you want to jump to a particular line, it uses these line numbers over here to the left. In APL, we could jump to particular lines as well, but it would get confusing really quickly if I were trying to read the code over here in the BASIC window that said, for example, go to 260, and then I would have to figure out, oh, 260 was line number 11, and somehow create a mapping between those two. So what I've decided to do is I'm going to use a label on those lines that I need to jump to, and I've just written these down off screen so that I can keep track of them. This line 110, which is just printing a blank line, is where we will jump back to later when we want to we'll ask the user if they want to play again, and then we can jump back to line 110 to do that. So I will do a label here, L110, and then the label's followed by a colon, and then printing a blank line is just an empty character vector. Okay, then we get line 160 where we're initializing the variables n and q both to 100. So we can do a multiple initialization here. We can do n gets with the left arrow. I used the wrong arrow there. Let me back up. I want a left arrow, n gets, and then q gets 100. Okay, let me redisplay my code. Okay, so that sets both the variables n and q at the same time. Now, line 190 is also one we'll need a label for, L190, and it's printing you now have Q dollars. So we'll write you now have, and then to separate character vectors from numbers in APL here, when those get printed, we have to use a semicolon. Then I can reference the numerical. Well, I guess it just doesn't matter if it's numerical or not, but I can reference the variable q and then finish with dollars, period. Okay, my next labeled line will be 210. So I'm on line 195, that's printing a blank line. Line 200, go to 260. So our go to or our branch operator is the right arrow, and again I'm using labels, so it'll be L jump to L260 or branch to L260. Now we're on line 210. We'll need a label for that line, L210 colon. This is if they've won. Then we're going to increase the amount by the bet. So Q gets Q plus M. And then we will jump to 190. Jump to L190. and then we're at line 240. This is if they've lost, we will subtract their bet. So L240 colon Q gets Q minus M. Line 250, go to line 190. Now, line 260 is reference, so we'll do a label L260 colon. Print, here are your next two cards. Here are your next two cards, dot, dot, dot. Okay, line 270 is referenced also. So starting here on line 270, we need to generate our random numbers, A and B. So they are using a particular random number primitive RND. I'm not sure what that gives them, but they multiply that by 14 and add 2, and then they re-roll if the number's too low or too high. And so we can do something much simpler. We're just going to get a number between 1 and 13. So line 270, this is the first card, so that's A. We'll get, and we'll use the roll, which is the question mark, of 13. And this will generate a random number between 1 and 13. And then we will get our second card. B gets a roll of 13. Now, we need to check these if we will need to re-roll A and B if A is equal to or larger than B. We want to end up with two cards that we can display easily, where card A is the smaller card and card B is the larger card. So we will jump back to L270. So we're going to do a right arrow, branch to L270. This will be conditional if A is less than or equal to B. So the way that we write if is the time symbol followed by iota. So the way that the jump mechanism works, this does a particular kind of a test that is essentially equivalent to an if. So then we put in our conditional value. So if A is less than or equal to B. Okay, so this will, it'll roll once, twice, 3 times, however many times are needed, so that we end up with this. And it's really fast, so we don't even notice the amount of time that it takes to do that. So we'll move ahead. They get ready to print the card A and the card B, but they jump to these places where instead of printing the upper card numbers, let's see, for Jack, which is 11, Queen is 12, King's 13, and Ace is 14. So they have to include some extra logic code to do that. Well, we can do something simpler. I'm going to create a cards vector that will include the cards in order from 2 all the way up to the ace. Ace is high. And then we will, to print out our cards, we'll just use a reference A and B into that vector. So you'll see how that works here. So create our variable cards, and it'll have 2, 3, 4, 5, 6, 7, 8, 9. Now I want all of these to be single letter or single digit representations of the cards to make this simple, and we can easily do that. We'll use T for 10, then J for Jack, Q for Queen, K for King, and A for Ace. Okay, so then we need to print card A and B. So I will reference the vector cards at location A and cards at location B. So that should print out both sets of cards, or both cards. I'll go ahead and I'm going to close the program and run what we have so far and make sure that the code runs well up to this point. So I'll use a del to end my definition, and I'll run the program just by typing in AC. So here are the instructions. Here's the amount that we start with. Here are two cards, 4 and 2. So something's wrong with my logic. I'm going to go back and double check what I've done in that instance. So we'll go back to define AC. I'll print the program. Okay, so I had line 17, L270, roll A, line 18, roll B, line 19, jump to L270 if A is, I have my logic backwards on that. Line 19, if A is greater than, or I want A to be smaller. So I want to re-roll if A is greater than or less than B. So you'll see how we fix mistakes. Didn't mean to make that, but this is illustrative, so I'm glad to do it. So I will just type in line number 19. Even though I'm on line 23, this will not put this code on line 23 because I'm putting the 19 here in brackets. So I'll do my jump again, jump to L270, and then times iota. And I want A if A is greater than or equal to B, then re-roll. Okay, so that puts us back on line 20. I'm just going to go ahead and print out all of the lines, so I'll be back here at line 23 again. Okay, so we've done the code here to print out our cards, and now we're down at line number 630. Let's see, line 650, which is doing a print, printing a new line or a blank line. And we need to reference that. So we'll do L650 colon and an empty character vector. Now on line 660, they're using the basic command input, which will print out what is your bet, probably with a question mark. And then whatever's typed in will be stored in the variable m. So we'll do this as two separate lines. We will print the question first. What is your bet? Question mark. And then we will put that in variable m. So m gets, and the way that we do user input for a number is with quad, which is shift of L. Okay, so now we have some logic to check what they've typed in for the bet. So if their bet was not equal to 0, then they jump ahead and continue with the program. If it is 0, it'll continue with the next line. It'll print chicken and a blank line and then go back to 260. So we could write that same code as well. We can also do something a little more here pretty easily. We can eliminate negative numbers as well. We could just print chicken if the number is 0 or less than 0. So I don't see any reason not to have that handle both situations here. So jump to L680 if m is less than or equal to 0. Okay, so now we're jumping ahead of the code that we're typing now if their bet was okay. So now if their bet was 0 or less than 0, we will print chicken with 2 exclamation points. Now this is a composed character that's made from the single quote and the period. So we type in the single quote, which is Shift K and backspace, and then type period. And we'll do that twice. So we print chicken and print a blank line, and then line 677 jump to 260. So we'll jump to L260. Now we're on line 680, and this is a line that we will reference, so we'll put in a label L680. If M is less than or equal to Q, so this is checking their bet to see if they have enough money. So the money that they have is Q. So if M is less than or equal to Q, then that's a good bet. So jump to 630. I'm sorry, jump to 730, L730. If, so I'll do times iota, M is less than or equal to Q. So if that's not true, then we will print, sorry, my friend, but you bet too much. And line 700, you only have Q dollars to bet. You have only Q dollars to bet. And then we jump to 650. Okay, now we're at line 730. So we get the random number for cards. The third card, we'll put that in C. So this line we will reference this one. So L, give it a label, L730. C gets another random roll of 13. And then we print that card C. So we'll do cards of C. That's line 810. And we'll skip ahead so we don't have to worry about the Jack, Queen, King, Ace. So we get up to line 910. So now we need to check. Did they win? Did they lose? So they've broken up the test of whether the person has won or lost into 2 separate lines. They check to see if the card C is bigger than the first card. If it is, then they jump to line 930 and they check to see if C is greater than or equal to the second card. And they jump to the losing condition if that's not the case. Oh, I'm sorry. If C is greater than or equal to B, then they've lost, so they jump up to the lose message. So we can do this on do this check on one line because we have the and or operators that we can use. I'm not evidently they couldn't do something that sophisticated, or they chose not to in this version of BASIC. So we need to figure out if they've lost, and then we'll jump to line 970 if they've lost. So we'll put in here jump to the wrong character. Jump to L970 if Now let's see, under what conditions have they lost? So if C, if the third card, if it's less than or equal to the first card, so if it's less than or equal to A, or if C is equal to or greater than B. So if C is greater than or equal to B. So in both cases, the card C was too low or too high. It wasn't in the middle. And we'll jump up to line 970, which prints out the sorry you lose message there. Okay, I'll enter this line. Okay, so we're jumping away to the lose condition, which means that now if we are on the next line, they've won, so we will print at line 950 here, you win, with 3 exclamation points. Okay, I didn't want to do that. Let's try this again. Okay, getting these composed characters are a little bit of a challenge for me. Okay, hopefully that's right. Nope, it wasn't. So I get a character error. I'll get to do that again. Print you win. Okay, and then so you win, and then go to line 960, go to 210. So we will branch to L210. Now, line 970, we've already referenced that because we needed to jump to the losing condition. So we'll do our label L970. Print sorry you lose. (980) If M is less than or equal to Q, then 240. So they've lost. If the amount that they bet was less than how much they have altogether, they can keep on playing. They didn't lose everything. So that's what this line does. Jump to L240 if M is less than Q. And then starting at line 1000, they've lost their money. So we'll print a blank line. We'll print sorry friend, but you blew your wad. And we'll ask them if they want to try again or not. So we will print try again. Now we can simplify this by just having them type in Y or N. We could have them type in yes or no, but then we'd have to put that in a character vector and check the first letter to see if the first letter was Y or, well, if it's Y or not, and do something that way. As far as I know, in APL, there is APL 360 anyway, there was no primitive for checking that one whole character vector was equal to another. You would have to, do something to check to do some sort of a Boolean comparison between the different vectors, and it would just kind of complicate our logic here. So I'm going to keep this simple and just use Y or N and a question mark. Okay, let me print that out to make sure that looks okay. So we have try again, Y or N, and then we're going to store that in AD. So we'll get variable AD gets And then to do a character entry, we do quote quad. So that's Shift L, and then I'll go back and compose that with a quote. And then on line 1030, if AD equals yes, then jump to 110. So we'll jump to L110 if AD equals, and in this case, we're just looking for the character Y here. So if they want to play again, jump back to 110. If they don't, we'll print a blank line and then print OK. Hope you had fun with a couple exclamation points. And then they end the basic program. We don't need to type end for ours. We'll just go ahead and close out the definition. Okay, so if we want to print the whole thing, and I'm outside of the definition editor, we can do AC, left bracket, quad, right bracket. Nope, we can't do that. I forgot my del at the beginning. I was going to run the program and then I decided, no, let's display it instead. So I'll do quad, AC, I'm sorry, del, AC, left, quad, right, and then another del. And that will print out all of the code. We could scroll up and down if we wanted to see the whole thing here. Okay, I'm going to run the program, and then we may have to do some more debugging. It's okay. So here we are. We have $100. Our first two cards are an 8 and a queen. What is our bet? I'll bet 10. Now, having played this before, I know that on other runs, when I've coded this up previously, the first two cards were not an 8 and queen. So we are not getting the same, starting with the same random number every time. So there is something that's randomizing the seed so that we're guaranteed not to always get the same sequence of random numbers whenever we run a program like this. So I'll bet 10. Okay, so here's a problem. What is your bet? 10. We get chicken. So we should be getting chicken if our bet was 0 or less than 0. So something's not quite right there. We'll try this again. So between 8 and 10, I'll bet 10. Okay, so something's not right. So we're going to jump out of the program. So this is how we break our input in APL 360. We use a right arrow. And now we can go back into the program definition. And we'll look at the code. Okay, so I'm going to look back up here at my line 26 and 27. So we get the bet. What is your bet? And then on the basic code, if the bet was not 0, then jump to 680. So for us, we're going to jump to L680. If the bet M is less than or equal to 0. I'm not seeing offhand what's wrong with that. Let's see. Get the bet on line 25, line 26. Jump to L680. So that should skip the chicken line. Oh, okay. So again, I made the same mistake here with my less than and greater than as I had done earlier. So we'll fix line 26. jump to L680 if m is greater than 0. So this means they did bet more than 0. And that's why seeing the result of putting in 10 and then seeing chicken, I figured I had got the something wrong with the conditional. Okay, so that line's fixed. I'll go ahead and jump out of the editor. We'll go ahead and run the program again. So 2 and 7, I'll bet 10 again. We lost. We got a 10. So here's the 10. Sorry, you lose. You now have $90. So 9 and ace, I'll bet 20. Okay, we got a king. You win. You now have $110. So a jack and king. I'll bet 0. We'll try uh, that. So we get chicken, and then we're given 2 more cards. So between 2 and jack, let's see. I'll bet everything. Those odds look pretty good to me. We win. So between 10 and jack. So I'm going to lose now and see about losing everything to see if that code works. So I'll bet all 220. And we got an ace, and we did lose. So sorry, you lose. Sorry, friend, but you blew your wad. Try again. Wire in. So I'll do Y. And we're back at the beginning. We now have $100. Here are 2 cards, 2 and 10. We'll bet 100. We got a king, so we lost again. Now we'll say no. Okay, hope you had fun. And then we're done with our game. Okay, so let me just display the code one more time before we end here. So here's the code. What did it turn out to be? 47 lines of APL, and I think it's fairly straightforward. In other videos that I've done over APL 360, I've explained a lot of the basics. But this is kind of the first big example of writing a complete program and kind of seeing live coding in a video of this format that I've made. And I hope that you have found this useful. And I look forward to making more videos in the future, not only looking at APL 360, but also earlier versions of APL that are not as modern as what we currently have with what you might find in a dialog APL or in a J or something like that. So thank you for watching.